Hi everyone, and welcome to section 7.1, which deals with the greatest common factor and factoring by grouping. So that's pretty much what we're going to do today in this section is find the greatest common factor and then be able to use that to factor by grouping. So let's get into it. First of all, just recall that a factor is what? Two things that when you multiply them together, it becomes something else. A product is the final result and factors are the individual pieces, right? So let's say, for instance, you have 56. The factors, one set of factors of 56 is 8 and 7. There are others, but that's just an example. So to get to the product, you multiply the factors and then that's your answer. But if you have the product, so the going from multiplication to, going from factors to product, you multiply, and to go back from, let's say you have the product and you want to go back to the individual factors, that process is called factoring, okay? Splitting a product into its factors is called factoring. Now, with expressions, it's no different. So let's say here you have 2x times x plus 3. If I was to multiply them, of course, I'd use distributive property. This is my product right here. So if I want to factor, I'm going in the reverse direction, okay? Okay, and then let's introduce the term greatest common factor. It's basically what you think it is. If you have two or more expressions, the greatest common factor is the largest expression that is a factor of all of them. In other words, it is the factor that they have in common, but the greatest one. Hence the name greatest common factor. Okay, let's go ahead and do a couple. So let's find the GCF of 54 and 36. Now there's a couple ways to do this. One way that will always work is if you do prime factorization. Ultimately, with numbers later on, you're going to realize that it's easier and easier just to get the largest number that divides into both of them. But for now, let's go ahead and just look at it this way. So factors of 54, 9, and 6, we can factor that into primes, 3 and 3. So these are primes. So we stop there. 6 is 2 and 3. Well, I don't know why I did a circle. 2 and 3. So that's that. Okay, so 54, the factors of 54 are 2 times 3 times 3 times 3. Okay, now 36 is 6 times 6, or 12 times 3. The great thing about prime factorization, it doesn't matter how you start, but in the end, you're going to end up with the same result because you're going to factor a term right into primes. So 36, the factors of 36 are 2 times 3 times 3. Okay, so what do they have in common? So the GCF is going to be comprised of all the common factors. Okay, so here's a 1. Okay, fine. They have a 2 in common. And then they have a set of 3s in common. And then they have another set of 3s in common. So the greatest common factor will be 18. So think about that. 18 is the number that divides 54 and 36 both evenly, okay? All right, so let's see. So that's the GCF. Let's do another one. 48, sorry. I don't know why I did that. 48 and 80. Okay, so 48. So 6 times 8 is 48. 80 is 8 times 10. I don't know why I did this way, but that's fine. 2 and 3. This is 2 and 4, and this is 2 and 2. So, 48 is split into, and you can circle it. That's fine. Circle the edges of your tree. 2 times 2 times 2 times 2, and then times 3. And then 80, we have here 2 and 4, 2 and 2, 2 and 5. So 1, 2, 3, 4, 5. Okay, so 2 times 5. Oh, times 2. There should be a 2 in here because there's 4 2s, right? Okay, so, your GCF is going to have the factors that are in common. So they have a 2 in common. They have another 2 in common. They have another 2 in common. They have another 2 in common. And then that's it. So your GCF is going to be 16. Okay, so 16 goes into both divides into 48 and 80. So, and it's interesting to think about because 48 divided by 16 is 3, and 80 divided by 16 is 5. So this is the highest possible number. If you could, usually people start asking the question at this point, like, could I have just skipped all of that and just noticed that 16 is the highest number I could divide and that there's no common factors left over? Yeah, sure. Of course you can do that. All right. Now here, and in fact, you're kind of expected to later on, at some point you start developing the sense of doing that, the more practice that you get. Okay. So, all right. So let's see here, finding the greatest common factor of two expressions. Now, what do you do if you have 27x cubed and 18x to the power 4? So you can do the same thing, right? With the number part, we're doing the prime factorization, okay, fine. And then 18, 2 and 9 and 3 and 3. So then we, 27, sorry, I don't know why I wrote 2x. Okay, 27, hello, work, sorry. 27, why isn't this working? Okay, it thinks it's still on, for some reason it thinks it's on, there it goes. 27x cubed, sorry about that, can be factored as 3 times 3 times 3. That's the prime part. But then the x cubed part, so x times x times x, there's 3 x's. And 18x to the power 4, that's 233. And then there's 4 x's here, right? So then what's in common, yeah? So then they have a 3 in common, so your GCF, I should have done that in this one. GCF is going to be 3. Here's another one, 3. Skip that. There's 1x, another x, and another x. So x times x times x. I guess if you wanted to be thorough, you could write that 9x cubed. Now you might say, oh, okay, well, I noticed that 9x cubed was in one of them anyway. And the variable part is actually easier because you can just use, you can just count, right? So when you have the common variable, you just get the highest, basically the largest amount of exponents that can divide into everything, which actually amounts to the exponent, the lowest exponent, if that makes sense. So let's say here you have x cubed. It's the largest possible amount of x's that can divide into both x cubed and x to the 4th. But if you were to compare them, it's the lower exponent, if that makes sense. Okay, so your GCF is 9x cubed. Let's go ahead and do a couple more. So GCF of 4xy squared, x squared y, and 6x squared y. So the number part is going to be easy, right? Because the only common factor they have is 2, right? And you can check that. And then what divides into x squared and x? Just 1x. Okay, so in other words, we keep this one. And then y and y cubed, well, you just can only, only y divides into both. Y squared would not divide into this term, So that's it. All right, so then here you have 21, x cubed, 9x squared, and 15x. So what number divides into all three? What's the highest number? Well, that's just 3. And then, what's the highest amount of exponents that can divide into all of them? Well, you look at the lowest one, and that's x. So that's it. Your GCF is just 3x. Okay. And you can do the whole thing where you break it apart. If you want, I'll do it for you this time. But you'll see it's better to start training yourself to think of it like this, the shortcut way, because you're going to be factoring a lot. So let's say here, this was 3 times 7, 1, 2, 3. 9x squared is 3 times 3, x times x. 15 is 3 times 5 times x. So the common ones, they all share a 3, and they all share an x, and that is it. Okay. All right. Okay. So now, what if you have a polynomial? So to factor out a GCF from a polynomial, you have to consider the distributive property You're like, wait, why? Because factoring for, let's say if you have, remember the distributive property. First of all, let's talk about it. If you have a number multiplied by a sum of other two numbers or variables or terms, then you distribute the outside one within the parentheses using multiplication. Okay, now that means that if I have the sum of two terms that share a factor, I can kind of do reverse distributive property and write this outside and leave what's left, in the parentheses. So inside parentheses would be the B and the C. Okay, so yeah, so let's say here, so to factor out the greatest common factor from a polynomial, the way you have to think about it is, okay, what's my GCF for 4x and 12? Well, that's just 4. 4 divides into both. So you have 4x plus 12. So you're going to rewrite that as 4. And then inside the parentheses, you're going to write what's left over. So 4 in your mind, or however, if you want to write it out, it's going to be kind of crazy. 4x divided by 4 is x, right? So that's going to be in here. And then bring down the same term. And then in here, you're going to, what's going to go? So 4 times what will give you 12? So in your mind, this is supposed to be a thought bubble, by the way. This is, I don't know. In your mind, you can think, okay, well, 12 divided by 4, that's 3. Okay, fine. So then 3 goes here, okay? All right, so that's it. So we factored it. So we can find the GCF for all terms. It's just to, restate this. Rewrite each term as a product. You can do that. And then you could skip step 2, but some people like to write step 2. You can use reverse distribution property, and then we check by multiplying the factors. I usually don't check, but you can. It's not a bad habit. Okay, so 6a times 24. So right away, I'm asking myself, does 6 divide 24? And it does. So I can think of, okay, so 6a is just 6 times a, right? Plus, and then 24, I can write as 6 times 4. So using their rule. So then I notice, okay, wow, they have 6 in common. That's my GCF. So my little thought bubble, that's you or me or whoever. So 6, so the GCF is 6 here. So then I go, okay, I can take this out, reverse, distribution property. A plus 4 is what's left, right? This guy's left and then this guy's left. So that's it. And then if you wanted to check, fine. So check just to be, let's say I wanted to check. I'll just use distribution property again. So 6a plus 24. So yeah, that's what I started out with. Okay, great. All right. So also, just to note, factoring is both a noun and a verb. So basically we say, when you use it in a noun, it's saying 7 is a factor of 14. Like that means that 14 is equal to 7 times 2. So that means that this is a factor, right? Factor. Okay. Now, a verb is, hey, factor 3 from 3a plus 3. That means like, hey, 3a plus 3, I'm going to factor out. So that's actually the process of, dividing it out or reverse distribution propertying out. Okay. So in this case here, factor 5a plus 5, it's pretty obvious what the GCF is, right? But just in case it's not, the GCF is 5. So then you would write that out of the parentheses. In parentheses, 5 times what? It gives me 5a, a. And then 5 divided by 5 is just 1. Okay, and then you can check if you want. It doesn't hurt to check at least maybe the first few times just to make sure that you start with what you. But this ultimately is your answer. This is the factored form, not the check. Okay, the check is not the answer. Okay, so let's go ahead and do that here. So GCF for here, 12 goes into itself. 60 divided by 12 is 5, so GCF was just 12. Okay, so 12. Okay, and then what's left? That's x minus, and then 12 times what is 60? We just said that, 5. So that's it. So then let's look at this. Okay, so what's the GCF of 4y squared, 24y, and 28? There's no variable in all three terms, so that can't be part of the GCF because it has to be in common with all of them. But 4 divides itself. It divides 24 and it divides 28, so GCF is 4. So if I divide that out or factor it out, right? So that's going to leave me with a y squared. So remember again, so you can, this is like, you can write this on the side. You don't have to do the thought bubble part, but you can write, like once you have the GCF, you can write to yourself, or you can just think it. Oh, okay, that's going to be y squared plus, and then here you have 24y. If I divide that by 4, what am I going to be left with? Oh, I'm going to be left with 6y. Okay, fine, that's 6y plus, and then 28 divided by 4, that's just 7. Oh, okay, that's what goes here. And then if you want to check it, you just redistribute it. Go backwards. 4y squared plus 24y plus 28. And then you notice that they're exactly the same. So yes, so then that's your answer. This one right here is your answer, right? This is factored form, right? So when they ask you to factor, you present something that is like a product, okay? Let's do a couple more examples for funsies. Okay, so here, what's my GCF for this one? Okay, what number goes into both 5 and 25? Okay, the 5 that's easy. How many variables, right? How many x's can go into both of these terms? Well, x squared is the highest amount, that can divide into both. But when you're comparing them, you just use the lowest amount of x's, so that's x squared. So I'm going to factor that out. So I'm going to write 5x squared. The GCF goes on the outside of the parentheses, and on the inside is basically, if you divide each term by the GCF, then the inside will be the result, okay, or the quotient. Or you can think of it as what number times, or what letter times 5x squared will give me 5x cubed. Well, that's just x. Okay, so this part will just be x. And then minus, and then here, this is going to be just 5, right? So you can even check that. So you get 5x cubed. Oh, sorry, this is a minus. See, I messed up. Okay, minus, sorry. 5x cubed minus 25x squared. And there you go. That's your check. Okay. All right. Let's do another one here. 8m cubed minus 12mn squared plus 20mn. So we need to find the GCF. Of course, that's the first thing we do. So what's the GCF of 8m cubed? That's fine. I'll write it out this time. 8m cubed. That's what divides into that. So I know that 4 is going to end up dividing into all of them. But let's just say I didn't. Okay, so 8, 2 times 2 times 2. And then there's 3 m's, right? You don't have to write this out every time. So 12 is 2 times 2 times 3, m times n. And then 20 mn squared, that's going to be 2 times 2 times 5 times m times n times n. So now we need to find out the common ones, right? So like I said before, in my mind, I thought, oh, 4 divides into all of them, okay? But now we're going to go ahead and do this, here they have a 2 in common. What do they have in common? They also have another 2 in common. Okay, fine. They have an m in common, 1m, right? And they don't have anything else that's in common. Notice this has an m and n, but this doesn't. This has an n and n, but this one doesn't have an n. So that's it, right? So again, notice that the least power of m is a 1. And also the least power of n is 1 also, but this one has no m. No n. None. Just means that there's no n there, so it can't be part of our GCF. So our GCF is 4m. And I apologize if you already knew that from looking at it, but I'm sure hopefully this will be helpful to somebody. So you take that and you divide that out. Again, so like you can think of it here. What is 8m cubed divided by 4m? You don't have to write all these steps out, by the way. If you're able to do this in your mind, that's good. But if you're not, if you're like me, I have to kind of ask myself, okay, what times 4 gives me 12? Okay, I know that's 3. M times what will give me m squared? Okay, that's 1m. Okay, and then it doesn't have an n, so I need to put that there. Okay, plus, and then here you have a 5, right? Because 20 divided by 4 is 5. The m, you already took that out, so then what's left is an n squared. Okay. All right, and you can check that. Let's do a few more, and then we'll be done with this factor by GCF. Okay, so here, the GCF, they have two negatives. So the GCF here is a -8. So then it's -8, and what's left is y plus 3. So that's it. Here, I can factor out a -7a. So GCF here can be a -7a. So if I do that, if I take out a -7a, that's basically going to leave me with a 1a and then a minus. Why? Because when you divide a negative by a positive by a negative, your answer will be -3. Okay, and you can make sure. So these two examples are here to make sure that you watch out for your signs. Okay, all right. So now let's talk a little bit. Oh, wait, no, let's do one more important example. Now look at this. This looks a little different, but you still have here two terms, except that each part is its own, set of factors, right? You have two factors here, 5q times q plus 7, and here you have 6 times q plus 7. Now, what's in common? This q plus 7 is in common. Okay, so that's our GCF. So in this case, our GCF is actually a binomial. Okay, so let's take out that binomial. So q plus 7, fine. We'll just factor it out. What's left? Okay, so what's left? After I take out that q plus 7, I'm left with 5q and then a -6. Okay. So that's it for that one. How about this next one? So these are really easy. n minus 4 is the GCF. So then I take out the GCF, so n minus 4, and I'm left with 8n and then plus 5. Okay, and that's it. Factored form. Okay, so it's good. So now we can do factoring by grouping. Okay, so what do? So if I have like 4 terms, more even, but usually it's 4 terms, I will you divide the first 2 and then the last 2, and then you separate the first 2, you regroup, and then you factor each group by GCF. Okay, so basically you group the term with common factors, you factor out the common factor in each group, and then we factor out the common factor. So it sounds kind of confusing, so let me unconfuse this. All right, so here we have 4 terms, yeah? We have 1, 2, 3, 4. I'm going to group these 2 together, and then I'm going to group these 2 together. So basically what I'm doing is I'm ignoring, I'm kind of like ignoring this. This is going to look weird, but just bear with me for a second. I'm ignoring this part for a second, okay? And I'm just focusing on the first 2. And I'm saying, okay, what's the GCF for these 2? Well, obviously, it's just a y, right? So I'm going to write y, and then what's left is x and 3. So that's x plus 3 on the inside, okay? And now I'm going to bring down this plus sign, and I'm going to look at the next 2. Okay, so now I'm going to say, okay, what's the GCF for 2x plus 6? Well, 2 just divides into both, right? So that's my GCF is 2. Okay, and then what's left in the parenthesis is x plus 3. Oh, sorry, I like to match. Okay, so now look at this. This is now y times the quantity x plus 3 plus 2 times the quantity x plus 3. So now the GCF is the binomial. Okay, fine. Cool. So I'm doing GCF again. So x plus 3. And now what's left over? I have a y left over. So y. And then I have a plus 2 left over, so plus 2. And that is it. That's factoring by grouping. So cool, right? Now you have something that it was 4 terms long and you factored it into 2 binomials. So let's go ahead and try this again. All right, so look at these first 2. What's the GCF here? Okay, it's a B. Okay, so B. Why did I do that? Okay, B here. And then what's left is an A and a plus 7. So A plus 7. Okay, and then plus, and then you think to yourself, okay, what divides into 8 and 56? Because I'm grouping these 2 together now, right? 8 divides into both. Okay, that's the GCF here. And then what's left over is an A plus, and then 56 is 8 times 7, so A plus 7 again. Okay, so now these 2 are in common. So I take out A plus 7, and I'm left with B plus 8. Okay. All right, I think I can do a couple more of those so you can see. So here I have x squared plus 2x minus 5x minus 10. So let's go ahead and regroup. So I'm going to look at these 2 and ignore this. So then my GCF for here is x. What's left over? X plus 2. Right? X squared divided by x is x. 2x divided by x is 2. Okay, now I'm going to look at this. Okay, these 2. What divides into both negative 5x and negative 10? A minus 5. I can do that. And I'm left with an x plus 2 again. Okay, fine. So then now I take out the x plus 2. And I'm left with x minus 5. And that's it. Okay, let's do this last one. You know, for funsies, even though it's the same kind. So here, y squared plus 4y, y, and then what's left is a y plus 4. Okay, now here, what divides into negative 7y, negative 28, minus 7, and then that's going to leave me with a y plus 4 also. So what that's in common, and I pull that out. Now, let me ask you guys a question. You obviously can't tell me like in person, but just for yourself, food for thought. What, how can I know that I'm doing the right thing? You know that you're correcting like you're factoring properly. You know, when you're factoring by grouping, you know it's correct when you have the same term here, the same binomial. If it wasn't the same, you did something wrong. Okay, so that means something happened or it's not factorable. Okay, so then what's left is y minus 7. Sorry. Ooh, I didn't know I could do that. Y minus 7. Okay. And that's it for this one. Okay, that's it for section 7.1. Good luck and happy studying. That's your homework, and I will see you in the next video.